Welcome and boa-vinda, that's Portuguese, to this lecture on more trigonometric equations. There's really no new content here. They're just at the end a little bit, and pretty much again we have to solve here something, and then the new thing is that, well, it's not really that new. Yeah, there's a cosine here, and then there's a secant on the other side, and so we try to get only one trigonometric equation in here, and of course it's not hard at all because we just use the reciprocal identity, 1 over cosine, and we're back to just one trig equation. So I'm going to do here this one. So this is going to come out to 1 over cosine x. There we go. Then we multiply on both sides. I think I'll write this down here. Reciprocal identity, and then multiply by cosine x on both sides, which means we're going to come up with 2 cosine squared minus cosine x equals 1. Yep, 1. Okay. Then, of course, we get the 1 to the other side and we make a substitution. So subtract 1 and substitute u equals cosine x. So we're going to have after we have subtracted the 1, that will be a equals 0. And then, of course, we have a u here. And then here we have a u. And then, hopefully, we can factor. I do like the quadratic formula, but when I teach, if I can avoid it, the better. We might actually have encountered this one already before, so 2u, and then it's either minus 1 here and plus 1 on the other side, or the other way around. In fact, this one is correct. 2u plus 1 times u minus 1. And then we resubstitute cosine x back into it. So we're going to have 2 cosine x plus 1 times cosine x minus 1 equals 0. And the solutions are, again, you can just scroll down on your screen, but at this point I might as well do that myself here. So we're going to have cosine of x equals negative 1 over 2. Did I write that down before? Yeah, I believe so. Yeah. Cosine of x equals negative 1/2. And cosine of x equals positive 1. And of course x comes out to, and we're supposed to be in radians between 0 and 2 pi. So this one here is going to be a reference angle of 60 degrees, and we're in the second and third quadrant, so we're at 120 and 240 degrees respectively, 2/3 pi and 4/3 pi. So 2 pi over 3 and 4 pi over 3. Pi over 3. And the other solution, cosine x equals 1, of course, only happens at x equals 0 radians. Okay, so that's pretty much how it works. The rest, of course, was algebra, just like we did in the last section, so there was nothing new. And the very first part, we had to substitute the reciprocal of 1 over cosine x for the secant x, and that wasn't really new either. Okay, let's go to the next one. And what are we going to do here? Solve for theta. Problem here. We have a sine here, we have a cosine here, and an additional problem, we have a 2 theta here. So there are 2 things here that we have to get rid of. We always just want to have it in one trig function. Well, should be relatively straightforward. Let's just try a double identity here. So sine 2 theta equals 2 sine theta cosine theta, and see where we end up. So this one is going to be this here. There's a 2 in the front, and then we have 2 sine theta cosine theta. Can we do something with that? Well, actually we can. We can factor out a cosine. So here again, I may want to write down double angle identity. And here I would write down factor out, and it's actually supposed to be a nice blue. There we go. Factor out cosine theta. So when we do that, we have cosine theta in the front. So it's gone here and it's gone over there. Of course, each one of them yields a 1, but we don't have to write that down. And the solutions, I think we can already see that theta equals, and this time around we're supposed to be in degrees. So on the first one, cosine theta equals 0 at 90 degrees and 270 degrees. And theta is going to come out to, well, this is sine theta equals negative the square root of 2 over 2. So that'll put us at a reference angle of 45 degrees. And with that negative, we're in the third or in the fourth quadrant. So we're at 225 and 315 degrees. And then let's see if I can borrow a degree sign here from somewhere. Way down here. There. Just makes it look nicer at the end. Okay. Let's just try one of the solutions, plugging it back in. Let's say we, as a check here, theta equals 225 degrees. We plug it in here. So we have sine of 450 degrees, which is the same as sine of 90 degrees, which is 1. So here we have a 1 for the first term. And then here we have cosine of 225 degrees, which is negative the square root of 2 over 2 times the square root of 2 here is going to be negative 2 over 2, which is negative 1. So we subtract the 1 from the 1 over here, and we come up with 0. And that means for 225 degrees for this check number, that's a true statement. And in the same fashion, you can do the others, or you can just graph this whole thing and look at the x-intercepts and really figure out this is where they are. Okay, solve for theta. Cosine 2 theta. Wasn't that the one where we have, for the double angle formulas, where we have 3 forms? And we do. So we're going to choose a convenient form. I would choose the one that is just in sines. And so cosine 2 theta equals 1 minus 2 sine squared theta. So we're going to do that. So again, a double angle identity. And so here we're going to have 1 minus 2 sine squared of theta. There we go. And then the rest is algebra, obviously. So we're going to have 2 sine squared plus da da da. Oops, actually there's a negative in front of it. I better keep that. and then the 1 is being added to the -2, so we come up with -1. And before I proceed, what I like to do is actually turn a negative around here. I don't like it in front of the square sign, so I'll do it on the next one. So multiply by -1, so we get plus here and a negative here. All the signs turn around. Do I want to try to do a substitution, x equals sine theta or u equals sine theta, or do I want to be confident and factor here with the signs in there? So pretty much what I have is 2 and -3 and 1. That's what I have to try. And I just try it with the signs without doing a substitution and see if I succeed. So in the front here, I should have 2 sine theta. I'll try that. 2 sine theta in the front, and here this one here will be simply a sine theta. And then I should have a, well, 2 -1s actually, so let's try that. Okay, now let's, after I factored this, I'm going to check if this is actually correct. It may not be. But if I lucked out, then that's great. So 2 sine theta times sine theta, as I FOIL this here, is 2 sine squared. Then the outer is minus 2 sine, and the inner is another -1 sine. So it's a -3 sine, just like it should be. And the last one is -1 times -1 is +1. So we factor it correctly. So here, factor should use substitution, but if confident, of course I am, and many of you should be as well, if not all should be confident of doing it, but if confident, just use sine theta. Okay. So the solutions are going to be theta equals, let's see, am I supposed to be in degrees again? I think so. So obviously these are not going to be the solutions, but I just copy them down and see what happens. So here I have sine theta equals 1/2. So I have 0.5. That means that puts me at 30 degrees. And second quadrant, 150 degrees. And then sine theta equals 1. And that, of course, puts me only at 90 degrees. So there are the 3 solutions. Okay, next example. Let's see, I'm going to scroll a little further so we have it better on the screen here. Let's see what I'm going to do on this one. I have a cosine squared in there, or I have a sine in there. I have to get rid of one of the two. What can I do? Can I substitute something for sine to come up with cosine? Well, I don't know. That there's nothing really convenient. Can I substitute something for cosine? There's also nothing convenient. Perhaps something substitute for cosine squared. Oh, there it is. Pythagorean. If I substitute the Pythagorean for this one here, I'll end up with sine squared and sine, and I can perfectly factor or use the quadratic equation. So that's what I'm going to do. Pythagorean identity that I substitute in here, so it's going to be parentheses here, 1 minus sine squared. And I like to have a nicer looking negative there. Okay. Now I'm going to do the algebra on this one here, so I'm going to do this all in one big swap here. I'm going to have 4 minus 4 sine squared, so I don't need the parentheses anymore. So I'm going to have a negative 4 sine, and I add that 4 here to the negative 5 in the back, so it's a negative 1. And then I switch all the negatives around, all the signs around, so that's going to be a positive. Oops. This one is going to be a negative, and that one is going to be a positive. Whoa, that was interesting. Positive. All right. Now I'm going to factor. So here I would say combine terms. And here, of course, factor. There could be 2 ways of doing this. One would be 2 sine times 2 sine, or one could be 4 sine times 1 sine. Let's try the first one first. 2 sine x in one parentheses and 2 sine x in the other parentheses, and then this one you should give us a negative 1, if indeed it is. We are able to factor. And a negative 1 over here. And now we double check. 2 sine x times 2 sine x is 4 sine squared x, and then minus 2 sine x, and that twice is indeed minus 4 sine x. Minus 1 times minus 1 is plus 1. So that is correct. In fact, what we have here is a perfect square trinomial. So instead of writing this here, I can just write 2 sine x minus 1 squared. So I'll be doing that. And factor will give a perfect square trinomial. Okay, which means that the solutions are x equals plus 1 over 2. So that puts us at 0.5, or reference angle of 30 degrees. And actually I'm supposed to be in radians, so it'll put us at pi over 6, and the other one is 150 degrees, so it'll put us at 5 pi over 6. So pi over 6 and 5 pi over 6. Okay. And one more problem. Okay. Sine theta minus cosine theta equals 1. Personally, to me, that's something that is bummer. The sine minus cosine single ones. If at least they were squared, I'd be virtually done here. But what can I do here? Probably many ways on how to do that. What can I substitute for sine? What can I substitute for cosine? Nothing really is convenient. Everything just will make it more complicated. Perhaps what I could do for the cosine is a Pythagorean. In fact, let me just do that. The book actually shows a little bit different here. What the book is doing is it adds the cosine to the right-hand side and then squares the whole thing, and then uses the Pythagorean. At this point here, I might just try that myself. Substitute the Pythagorean for one of the two, for example, the second one. So what I have is let's see, sine theta. Now I substitute for the first one here. Sine theta equals square root of 1 minus cosine squared. That's what I'm going to do. I think I'll use the equation editor for that. So it will look as follows. Square root of 1 minus cosine squared theta. So that's a Pythagorean substitution for the sine. However, when I do that with the Pythagorean, where I take the square root, I also have to add that, and that's actually plus minus. and then I write behind that minus cosine theta. I'm just going to do this a little bit different than from the book, simply because there are several approaches, and that way you get two approaches. You get one from me, and you get one from the book. So here, of course, it looks more complicated, but at least we just have it in cosines, rather than a mix of sine and cosine. Okay, what are we going to do with that? Well, like to get rid of that square root there, but don't do that right away, because then you really get a mess. Do instead, or do first, add the cosine to both sides. So I'm going to do that. Add the cosine to the other side. There we go. So pretty much, yeah, what I did there is use the Pythagorean and then isolate the square root. And now, of course, square both sides. So square both sides. And when I do that, I get parentheses on the right-hand side. Parentheses here, and then I can square that. And then, of course, I got rid of the square root here. It also has the added benefit of that I get rid of that plus minus there after I squared, because that obviously is just going to be a plus there. Now it looks already a little bit better. Notice all that algebra started out as a really simple one, but then in order to actually solve it, it takes all that algebra. So sometimes that happens. You know, have a simple one there, and then you get a complicated algebra involved there. Let's see what we get. Oops, how did that happen? So here, expand. So on the right-hand side, we're going to get 1 plus 2 cosine theta plus cosine squared. That makes sense. Or we know how to do a perfect square trinomial, so it's going to be 1 plus 2 cosine theta plus cosine theta squared. And then we put everything on one side, so we add cosine squared on both sides. So this one here, so we get a 2 cosine squared over here, and then we subtract that 1 on both sides, so we get a 0 here, and we get a 0 there, which of course we don't have to write anymore, and we don't even have to write that plus anymore. Here we go, and now what we do on this one here is actually really straightforward. We factor out a 2 cosine theta, and so doing, as we factor that out from the first term, a 1 is left behind from the second term. The 2 has been factored out, and one of the cosines has been factored out. So we're done. Solutions. Theta equals, do I have a theta? Yep, there it is. And I believe I'm supposed to be in degrees. No, that's not true. I'm supposed to be in radians. So theta equals, for the first one, we have either 90 degrees or 270 degrees. So we have pi over 2 and 3 pi over 2. So pi over 2, let's see if I have that earlier. Yeah, here it is. So pi over 2 and 3 pi over 2. And the other solutions are cosine of theta equals -1, so 180 degrees, or simply pi. And then, so we're done at this point. Then it says actually we're supposed to graph this as well. Or hold on, I actually say that we have to graph it, and you will see something interesting is going to happen there when we graph this. So we're going to graph the original one, sine minus cosine minus 1 equals 0. That's what we're going to look for, and we'll see what we come up with. We're supposed to graph it in radians, so I'm going to go over to the graphing calculator. Let's see. Sine minus cosine minus 1. I'm going to go to this correct, yep, and then we're looking for the x-intercepts, of course. I'm going to look for mode, so I have to be in radians. I'm going to look at window. I change that to between 0 and 2 pi. And I might as well put my scale into fractions of pi. Gee, I don't know how that happened there, that preview. Fractions of pi, oh, yeah, maybe pi over 6. Might work. Or what are we expecting here for solutions? Yep, pi over 6 will work. Second, pi over 6. And then here, negative 2 to 2 maybe. Shouldn't be more than that. Well, I'll make it negative 3 maybe. Alright, let's see what we get. Okay. Our scale is pi over 6, respectively 30 degrees, so we are at 30, 60, 90 degrees, or pi over 2. That's one of our solutions that we have determined. In fact, let me just take a screenshot, copy it, and go back to Word and plug it in there. There we go, scroll down. So, indeed, pi over 2 is a solution right here, and then here is 120, 150, 180, and pi itself is a solution. But what about this one here? It doesn't show up. 3 pi over 2. That should be here, right there. Where is it? It said that we're supposed to come up with. Well, here's one thing that we have to pay attention to when we do these substitutions with the Pythagorean and taking the square root and squaring the square root. What happens here with that plus minus in the front, we might introduce an extraneous solution. We had encountered that in algebra before. These extraneous solutions, they do happen when a square root is being squared, that we come up with more solutions than they're actually there. So this one here actually does not work. I'm going to cross this one out. Actually, I don't know how well that showed in Word. This one here is an extraneous solution. And with that one, I'm finishing up this lecture on more trigonometric equations.